Hello again, everybody. If you liked the last series of videos where we handled the 2003 Fryer, you're going to love this video because we're going to be tackling the 2004 Fryer contest. So how about we jump right in and take a look at it. So if we're looking at the Fryer contest, one of the first things you might notice is it still doesn't have the usual preamble that we've come to know and love from contests put out by the CEMC. Another thing you might notice, if you remember the 2003 Fryer videos, is there's no sort of problem extensions. This is something they had, I mentioned it in the last videos, they had these sort of problem extensions in 2003. They seem to have dropped those in 2004 and beyond. But other than that, not a whole lot has changed. It's still the grade 9 contest. We still need to sort of justify our answers. So, not a whole lot else to say. How about we just take a look at the first question? We'll get right into things. So, question number 1. Lloyd is practicing his arithmetic by taking the reciprocal of a number and by adding 1 to a number. Taking the reciprocal of a number is denoted by an arrow with an R over top, and adding 1 is denoted by an arrow with an A on the top. R for reciprocal, A for adding. Here's an example of Lloyd's work, starting with input 2. So he starts with the number 2, he takes the reciprocal. He gets 1 over 2. And then he adds 1 to it. That's what the arrow with the A over it is. So 1/2 plus 1, 3/2. Then he takes the reciprocal, he gets 2/3. He adds 1 to that, he gets 5/3. Then he takes the reciprocal of that, so 1 over 5 divided by 3 is 3 divided by 5, so 3/5. Okay. So, part A, using an input of 3, fill in the 5 blanks below. So we're going to start with the number 3, we'll take its reciprocal, we'll add 1 to that, we'll take the reciprocal, we'll add 1 to that, and we'll take the reciprocal. So we just need these 5 steps. So let's just dive right in, practice our arithmetic. Oops. Alright. So we'll start off with a 3, and we want to take the reciprocal. We want an R, not a B. There we go, got my eraser back. So I'll touch up this arrow just the tiniest bit. Alright, so reciprocal of 3, well that's just 1 over 3. Not too difficult. Then we're asked to add, so we get 1/3 plus 1, which is 1/3 plus 3/3, 4/3. Okay. Next we were asked to take the reciprocal, so 1 over 4/3. Well, we just flip the numerator and denominator, we get 3/4. Then we're asked to add. So 3 over 4 plus 1, we add 1 anytime there's the capital A. So you can work it out by hand, or if your calculator has a nice sort of fraction style function, you can do that. We get 7/4 out of that. And we were asked one more time to take the reciprocal. Let's just write all these nice and neat. So R 1/3, A was 4/3, R gave us 3/4, then we had 7/4, and finally 4/7. Alright, fantastic. And that was all we were asked to do in part A. Very simple, just getting us used to the problem. Okay, reciprocal add, so that was 4/3, 3/4, 7/4, and 4/7. Okay. B part. Using an input of X, use the same operations and fill in the 5 blanks below. Okay, so now we're not actually going to be doing computations we can do on a calculator. We're going to be doing sort of algebraic manipulation. So we're still doing reciprocal, then add 1, reciprocal, add 1, reciprocal. but we're going to leave this input x in here. Okay. So if we start with x and we take the reciprocal, we get 1 over x, plain and simple. So if we add 1, we get 1 over x plus x over x. That's 1 over x plus x. The reason we sort of simplified that together is because I know the next step I'm going to have to take the reciprocal on, so I want a single fraction so I can easily manipulate my reciprocals. Okay. I take the reciprocal. Well, that's 1 over 1 plus x over x. So that's going to be x over 1 plus x. All right. How about we add? So we'll do x over 1 plus x plus 1. So that's x over 1 plus x plus... Remember, we need a common denominator in order to add these things. So that's 1 plus 2x over 1 plus x. And finally, we do one last reciprocal, and we get 1 plus x over 1 plus 2x. So that should be the answer. Now, before we write it down nice and neat, what we could quickly do is, we know what happens if we put 3 in there. We should get 4/7 out. So what happens if we put 3 in for x? We should get 4/7 out. We get 1 plus 3 over 1 plus 2 times 3. Well, that's 4/7. So the whole thing worked out. So we just write down our answer nice and neat. So we got x, 1 over x. Don't forget to add in these r's and a's. X over 1 plus x. A gave us 1 plus 2x over 1 plus x. And the final reciprocal gave us 1 plus x over 1 plus 2x. Nice, clean question. I imagine we'll probably be substituting something else for x, but let's take a look at C part to see if I'm right. So using the 5 steps from B, all right, fantastic. So well, the work we just did. What input should you begin with in order to get a final result of 14 over 27? Okay, so we're going to need to substitute that in for our final answer and work our way back and figure out what the x value should be. And they ask us to justify our answer. Okay, so we'll have to do a little bit of writing, but not a whole lot. So I'll get ourselves a new piece of paper. So when they ask us to justify, we just need to explain what we're doing. So after those 5 steps, what do we have? What do we get? We get 1 plus x over 1 plus 2x. So we had 14 over 27. Over 27, we can equate this with 1 plus x over 1 plus 2x and figure out our input value of x. So 14 over 27 equals 1 plus x over 1 plus 2x. Well, I don't really like fractions, so what we're going to do is we're going to multiply this whole side by 27 times 1 plus 2x, and this whole side by 27 times 1 plus 2x, and what we'll get out is 14 times 1 plus 2x on this side equals 27 times 1 plus x on this side. Okay, so we expand out these fractions. We get 14 plus 28x is equal to 27 plus 27x. Okay, well, we can collect like terms, collect all our numbers onto one side, collect all our things in terms of x onto the other. Okay, 28x minus 27x, that's going to be 1x, or just x by itself. And 27 minus 14, that's 13. We make a little statement. So if we have a value of 13, that's what the numbers came out to work to tell us. It's not 27, it's 14 over 27, that's what it is. Nice clean therefore statement so the markers can follow what we're doing and give us full marks. If we wanted to, if we had time, we could come back and actually perform these steps, starting with the number of 13 and then get 1 over 13 and then get 14 over 13, then 13 over 14, and finally 14 over 13 and then 27 over 14. And then finally 14 over 27. So we could come back and actually write those out if we wanted to. We could just double check. We don't have to. If you want to, you can do it in your head. But again, not necessary. The math has spoken for itself. Checking is always good, but don't sacrifice time on the contest for the sake of checking for such a simple question. Check if you're unsure. Don't check if you know what's going on with the question. Alright, and we just double check. Always got to read through the questions carefully. So using the 5 steps from B, what input should you begin with to get a final result of 14 over 27? Justify your answer. Okay, so we did everything we were asked for. And that gives us question number 1. Nice little question involving some algebraic manipulation and then some solving for a value of x. So I hope the next question is just as good. But we'll take a look at that in the very next video. Thank you so much for joining me. I'll see you guys next time.